Okay, so let's look at this problem. If I look at the PDE, notice it is not written in the kind of standard form that I want it to be written in. So I'm going to first rewrite it into standard form. The t derivative of u plus 3 times the x derivative of u is equal to minus 2u. Okay, that's the rewriting step. So now I want to look at the region that I'm given and the Cauchy data and kind of sketch that. This is the step 2, finding the Cauchy curve. So omega is going to be the right half plane, x greater than or equal to 0, and x greater than or equal to t. So let me draw some axes here. This will be the t-axis, and this will be the x-axis. And I want x greater than or equal to 0 and x greater than or equal to t. So I'm going to draw x is equal to t. Okay, so in other words, it's all this area down there that we're worried about, or that whole area there, x greater than or equal to 0, and x greater than or equal to 0. X greater than or equal to 0 and greater than or equal to t. Okay, so what is the information that I'm giving? What is my Cauchy curve? Well, I've got u of x, 0 is equal to 1. So in other words, I know what u is along the x-axis. And I also have u of xx is equal to 1 plus x. So I also know what x is along this line right here. Okay, so now I've got my Cauchy data, my Cauchy stuff. Now I want to get the characteristics. So t dot is always going to be the thing multiplying the t derivative, so that's 1. Now, what t of 0 is going to depend on whether I'm on the x-axis or this line, xx. So why did I put it on that line? It's because u of xx, I'm looking at u along the line where y is equal to x. Sorry, t is equal to x. I'm looking along the line where t is equal to x. Okay, so t dot is equal to 1. T of 0 is going to be t naught. Again, we're going to have two different choices, whether I'm on the x-axis or this y equals x line. X dot is going to be equal to 3. And again, whether I'm on the x-axis or the line is going to depend on what x naught is. Though x naught is always going to be a generic x naught. T naught is either going to be, I can be a little more specific here. T naught is either going to be 0 if I'm on the x-axis, or it's going to be x naught if I'm on the y equals x line. So I'll do x naught or 0. And then z dot is always going to be equal to minus 2z. So that's everything on the right of the equal sign. So this is minus 2z. And then z of 0, well, again, if I'm on the line y equals x, the blue line, is going to be 1 plus x naught. And if I'm on the x-axis, it's just going to be equal to 1. Okay, so I'm gonna break this into two. I'm gonna first look to see what happens if my characteristic begins on for characteristics that pass through the blue line, y is equal to x. Okay, let's look at this point right here. I'll call the coordinates of this point x naught, x naught. Let's solve for the characteristic. Well, t of s, so t dot of s is going to be equal to 1, and t of 0 is going to be equal to x naught. So t of s is equal to s plus x naught. If I look at x of s, x dot is equal to 3, so this means x of s okay, so I forgot where I left off because my pen stopped working again, but I think I was doing x. So x of s then, if I'm on the t equals x line, x of s is going to equal to 3s plus x naught. And then z of s, oh, this went away somehow. It's going to be 1 there. Okay, so z of s is going to be equal to z naught times e to the minus 2s. But if I'm starting on the t equals s line, z naught is equal to 1 plus x naught. So this is 1 plus x naught. Okay, so let's sketch some of these characteristics. This is one of them right here. I already did that. It's a line going through the t equals x line with a slope of 1/3. So I'll have some other ones like this. Okay, and then this is supposed to be just anyways, this is supposed to be for x naught that lies on that line. So if it lies here, this is also on that line. So I'm going to do something like this. Okay. Now I want to solve, given a generic AB that lies on one of these blue characteristics, what is the value of the solution at one of those characteristics? So I know that U of AB, I know that U is equal to Z, or Z is equal to U on the characteristics. So U of AB is going to be equal to 1 plus x naught e to the minus 2s. Now I need to solve for s and x naught in terms of A and B. So I'm going to use my equations for that. So I have B is equal to s plus x naught. And then if I look at my A equation, this is going to be A is equal to 3s plus x naught. Okay, and notice what happens if I subtract the B equation from the A equation. I'm going to get A minus B. 3s minus s is 2s. X naught minus x naught is equal to 0. So this tells me 2s is equal to A minus B. Okay, on the other hand, if I look, for example, at my B equation tells me that x naught is equal to B minus s. But s is just half of 2s. So this is B. This is equal to B minus A minus B over 2. And I can simplify this. This is going to be 2B minus A plus B over 2. Or this is going to be equal to 3B minus A over 2. So on this side of the plane, I have U of AB is going to be equal to 1 plus x naught, which is 1 plus 3b minus a over 2 times e to the minus 2s. But 2s is a minus b, so this is just going to be e to the b minus a. So minus 2s is going to be b minus a. Okay, good. So now let's do something similar for the orange characteristics. So for the orange characteristics, this is going to be characteristics that pass through the positive x-axis, the x greater than or equal to axis. Okay, here t of s will be equal to s because t naught is equal to 0. X of s will be equal to 3s plus x naught. And z of s is going to be equal to z naught times e to the minus s, but there z naught is just equal to 1, so this is e to the minus 2s. Okay, so again, my characteristics are going to have slopes of 1/3, and there's also going to be, so the one going through here is going to be both a blue and an orange characteristic, and we'll talk about that in just a moment. The other ones are going to go through here, and they're going to have slope of 1/3. And since we're including the bottom part, the t less than or equal to 0 part, we can also, or should also, extend the characteristics that way. And all of these orange characteristics are parallel. Okay. So now, similar to before, I know u of AB for this part. U of AB is equal to e to the minus 2s. Well, I know here that s is equal to t, so this is just e to the minus 2t. Okay, so now, what do I have? I can write my solution. So u of x, in terms of b, this is b. So u of xt is going to equal, so I'm going to, for this right here, I'm going to go ahead and get a common denominator. Actually, no, I'm not. This is going to be 1 plus 3t minus x over 2 times e to the t minus x. This is when we're in the blue part Okay, of course, we're going to need to write that in terms of inequalities. And then we're going to have e to the minus 2t when we're in the orange part. Okay, well, how can I actually write that in terms of inequalities? Let me just copy this down and then I'll scroll back up. So this is 1 plus 3t minus x over 2. Having trouble writing a 3 right now. 3t minus x over 2 times e to the t minus x. And this is just going to be e to the minus 2t. Okay, so the dividing line, this is the dividing line. This black line that I'm tracing is the dividing line right here, and this is t is equal to 1/3 x. T is equal to 1/3 x. So if x is less, if t is greater than 1/3 x, if t is greater than 1/3 x, this is the solution, and if t is less than 1/3 x, this is also the solution. Okay, and I'm actually going to put less than or equal to there, and I'm going to talk for a minute about why both of these solutions. So to have a continuous solution, there should be a continuous solution here. There's not a shock or anything like that. For the solutions to be continuous, if I plug in t is equal to 1/3 x, both the top and the bottom function should give me the same formula. And so let's just kind of check this. If I plug in t is equal to 1/3, then in the parentheses there, if t is equal to 1/3 x, then in the parentheses, I'm going to have t plus, well, it's going to be 3 times 1/3 x minus x over 2. So notice that is just going to be x minus x, so that's 0, so that's equal to 1. And then if I look at the e to the t minus x, let me just do it like this. If I look at t minus x, and if t is equal to 1/3 x, this is 1/3 x minus x, which is minus 2/3 x. Okay, so if I plug in t is equal to 1/3 x, I'm going to get 1 times e to the minus 2/3 x. And if I come down here and plug in t is equal to 1/3 x, I'm going to get the same thing. So this is just a little verification that our solution is continuous on this like seam where the two different solutions meet. Okay, that's it for this problem. I hope you enjoyed it.